Hello and welcome to another mini lecture in CS200. Today we'll talk about GUI and how it works with Java. So specifically that's subchapters 17.1 through 17.9. So let's get started. So with Java, a graphical application displays its contents inside of a window. These look like pop-up windows. And this is what we call a JFrame object. The JFrame object has a couple of important components. I don't have an example of this one in particular inside of BlueJ, but there's a couple of things that are highlighted here that we want to point out. The first is we need to import the Java X Swing JFrame as our library. Then we have our main. Inside of our main, what we do is we create a new JFrame. So that's a new object. And inside that app frame is the name of the object that we're creating. So inside of that, we set the width and the height. So 400 by 250, and that's done by the set size. Typically, that's the first thing we do because that sets the kind of the canvas for what we have to work with. Next, we set the title, which goes up on the title bar. And then we tell the program what to do when the user closes the frame. We can sometimes pop up another window, for example, but typically what we want to do is we just want to close it. If we pop up continuous windows, that's really annoying. I'm sure you've seen that on some websites. And then what we want to do is we want to make sure it's visible because we could have an invisible frame. Again, what's going to show is something that looks like this, where we have the dimensions, the title, the characteristics of what happens when we close the frame, and then also we've got it made visible. What the JFrame does is it creates kind of a frame, just like the name mentions, but obviously we want to do something with that frame besides display a blank screen. So one way we can do that is by adding components. So a JComponent is a blank graphical component that a programmer allows to customize to draw some basic shapes. And again, Java is not designed as a graphical language, so we have some limitations to what it can do. Here is one example to show how to create a class. Notice that we're creating a class here to extend JComponent to draw some very basic 2D graphics. So again, we import some libraries, both graphics and graphics 2D, and we've already got the JComponent from our last example. We create a new class called MyCustomComponent, which extends the JComponent. So we're going to essentially take and extend the features that are already built into JComponent. We have to override a paint component because what we want to do is we want to create a graphics object, a 2D object. And then here's where we would write the instructions. So here is an example of drawing a histogram in a frame. It's a really basic histogram that allows us to modify the color and the size of a bunch of rectangles. So again, we've got a histogram component that's going to extend the JComponent abstract class. Then we're going to just draw a histogram with 3 rectangular bars. And we do that, we have a rectangle and color. So we're going to set the dimensions of the rectangle. We're going to indicate in RGB format what the color should be. And then we set the color on the object, and then we fill it because we don't want to just have it as a frame. We want to actually color it so it's a solid object. We do that 2 more times. So the first one is bin rectangle 1. We have bin rectangle 2 here, and bin rectangle 3, all of which need to fit within the object that we've created, the frame. Then we also have a histogram viewer class. And what that does is that uses the JFrame. So going back up, we can see that this one is using JComponent and a bunch of AWT libraries. In this one, we are using the J-frame, and we're designing the frame in which that particular histogram is going to appear. So remember what we need to do. First of all, we create the new J-frame object we called AppFrame, and then we create a new component. You can see here how we do that. Then with AppFrame, we set the size, we set the title. The third thing is to tell what it's going to do when we close it. And the fourth thing is to make it visible. In between that, we need to add the histogram component here. So what that does is that one adds the histogram component by calling histogram component here, which is going to create these three objects. So what it's going to look like when we're done is something like this. So let's look at some of the components that are involved with the example we saw. So what happens first is we're creating a new rectangle and we're giving it the dimensions. The next step has us determining the color of the object. After that, we need to set the color on the particular object. And then last, we tell it we want to fill it. One thing we need to realize is, unlike in most coordinate systems where we have it down in the bottom left, in this one it's in the top left, or the very northwest corner of the screen. In this case, we measure from that particular dimension axis there. We can determine the location of any of the shapes that we want to display. Here are some of the common shapes that we draw. Typically, we will draw a rectangle or a round rectangle in 2D. There's the ellipse, there's the line, and the polygon. So, of course, the polygon is going to be rather cumbersome to draw, and you can just imagine how detailed that can be. Now let's talk about graphical user interfaces, which is often referred to as a GUI or GUI. So Swing has some GUI components, and Java supports these sets for the development of custom GUIs. Now a GUI, or graphical user interface, enables the user to interface or interact with the program through these GUIs. So in the previous example, all we did is display information, and that could technically be considered a GUI. But what we want to do is we want to have some kind of interaction with some data. So instead of the text-based interfaces, here we're using different components. We saw some of them in the previous example, such as those histograms. So here I have example 17.2.1, which has us display a salary in a GUI. So if we have an hourly wage of 20, we basically declare that as an integer. And we create a J-frame, which is our application window, and then a text field, which is going to display the output salary. What this does is takes an hourly wage and creates an annual salary. So we have the text that we want to set, and we use these variables. So they use 20 here, and they create a new output field. And that's something that we have to do. We have to tell it that this area is going to get this text. How we set the text is using the set text command or set text method. So we can make it editable, yes or no. We set this to true, the user can edit it. We create the window and we give it a name, so we call this salary. Then we want to add the text field to the window, and this is how we would do it. We want to resize it. And remember the other things we need to do. We need to tell it what's going to happen when we close it. Otherwise, there may be no action. So you're trying to close it and it's staying live. And last, we need to make it visible. So we've got it built. The last thing we do is show it. So let's go ahead and compile this, close it. We'll go ahead and run it. So up in the very far corner, all we're seeing here is it's going to display salary. And then it says an hourly wage of $20 an hour yields $40,000 a year. Very basic, but it does what we need it to do. So one thing that's nice is we're able to use the pack method, which determines the preferred size. So when we resize the window, it allows certain dimensions to increase or decrease depending on which direction we're going. So just realize that when we resize a window, we have the ability to size the components using the pack method. Next, we're going to talk about how we can position these different components using what's called a layout manager. We have something called a grid bag layout. So this positions them in a two-dimensional grid, and this allows us to position things where we want them to be. So let's go take a look at our example in BlueJ. So again, we're using some grid bag constraints, grid bag layout, inserts, and then we have some swing libraries that we're using here. And notice these are Java X as opposed to just Java. So we declare a class called salary label GUI. And what this does is we're going to create an application window, and then we have to create a bunch of labels for the hourly, yearly salaries, and then we're going to display them. So there's a lot of steps involved with just displaying a window. When we talked about objects and classes, and we said that you're going to perhaps override some of these or extend them, keep in mind that what we're seeing here would be extended. So for example, once you've created a window, and you've got the look and feel right, you might extend those features to new methods or new classes, and then it's just making sure that you're working with very little differential information. So if we created a window with a certain look and feel, just by replacing the labels, we can have it look identical to a previous window. So here we are setting the hourly and the yearly salaries, and then we're also going to create a frame and add components using the grid bag layout. So here we specify the grid location, and then we're going to put some padding around each of these. We're going to add a component, the labels, and then we're going to make some conversions where we calculate the hourly wage. We put out a frame, and then we put the layout and some of the constraints. So the constraints are going to be the grid bag constraints, which we have here. So it's going to be a component layout. Again, very abstract at this point. Then we can specify the component's grid location, the padding. We have some information where we put the grid, we put the inserts, and you can see that they're very consistent. So 1, 0, 0, 1, 1, 1, and then we'll have what goes in each location. So let's take a look and run this and see what happens. And notice here, we're going to resize the window to fit the components. We'll look at that as well. Let's compile this, close it, and run it. So here we have these two components. So we had these 4, and we had them in a grid. So 0, 0, 0, 1, 1, 0, and 1, 1. And let's see, as we resize it, we can see that it tries to adjust, not very well, but it tries to adjust to the pack. So you can see that it moves around a little bit. Again, we haven't got to the point where we can modify these. It's just displaying information at this point. Let's take a look at this and how it works. So initially, what's going to happen is we're creating these objects, right? Next, we're going to put this information in certain objects. So we have a label object and we have a text field object. And again, when we think about the label objects and the text objects, we can see them here. So those have been created. Now we go to the next step. We're creating the frame. So this is what we've been doing all along. And you can see we've got this in grid format. We're going to specify which of these items go in which position. So here we are mapping them. And that looks exactly like what we have come up with here and what we saw with the example. So again, what can we do with the grid bag constraints object? Well, one of the things is to specify the location, like row and column of a component. We can also specify the minimum padding, and then we can specify the width or the height of the component. So let's take a look at another different coding style that defines a custom JFrame class. So this is using inheritance, which we already have talked about. And what inheritance does is it allows us to extend JFrame, and then we have salary label frame. So let's go back up and look at the previous example. And here we didn't extend anything. So the difference here with this example is we actually extend the JFrame class, and we are able to do things a little bit differently, but with the same effect. Again, we've already talked about constructors, so you should be pretty familiar with them. So this automatically is done when you call an instance of the containing class. So by doing this, we can preserve what that particular class should be doing when you have called it and created it. So far, we've displayed a lot of information, but we haven't really got any information back from the user. So let's see how we can interact with the user. How we do that is by using an action listener. So we can enter a wage for a yearly salary calculation by doing the following. Let me go to BlueJ and take a look there. So again, we have these AWT, which stands for Abstract Window Toolkit. These are part of an API to design different components. And we also have these 3 Swing libraries that we're going to bring in as well. So we create a class called SalaryCalcFrame, which extends JFrame and implements Action Listener. So we're familiar with what extends does with an abstract class and implements does with an interface. And here we're using them both together. So we have a bunch of private variables that we've set. We have our hourly and yearly salary label, as well as the display. So now we're going to use a constructor. And what the constructor is going to do is it's going to create the basic GUI components, and it's going to add several components using that grid bag layout, which we've already discussed. So I'm going to go over this quickly. You can see that wage field is a new JText field. We're going to put 15 in there. We're going to set it editable to true, which now allows us to have access to it. And then we're going to set the text to 0, and then we're going to add an action listener, which is going to allow it to interact with us so that we can change values. Then we also set a JText field here. We go through the grid bag layout to lay the items out in the order we want. We also set the size and the padding around those elements. So this, with the grid X and grid Y, as you know, puts the location in a tabular format. And then we go through and we do the things that we need to do. So these are our calculations. And remember what we need to do. We need to create a new frame. We need to tell it what it's going to do when we close it. We're going to put a title bar up on the top, but we haven't done that in our main. We're going to use the pack, which basically just resizes it to the size of the window. And of course, we need to set visible to true so we can actually see the object. So let's compile it. So when I run it, let's take a look. First of all, I notice that it's a lot slower than our previous programs. So then if I change this, say, for example, to 9 and hit enter, it calculates the value. And if I change it, say, to 15 and hit enter, it changes it once again. What this means is it's getting input from me. Notice the white box as opposed to the grayed out box. And it's changing that and making a calculation. So this is what we want to happen. What's nice is we have a lot of control over what our window will do at the cost of having a lot of coding to do. So you can see here that the code took there's a lot of code just to write a box that does a very simple task. With this action listener, we have a lot of control over what happens. However, we have to specify when the user enters values, how it's supposed to respond. One other thing we can do is we can add a button. Remember how I had to hit enter to get the values to calculate? What if I had a button? Wouldn't it make it a lot nicer? Let's see how that would work. So once again, here's my component, and I have a bunch of AWT, and now I've added another swing component called JButton. You can see that here, which I didn't have with the last example. So I call this class SalaryCalcButtonFrame, which both extends JFrame and also implements ActionListener. So you can see here I'm advancing my abilities in Java based on what we've learned. So the only addition here is this JButton, which I also have to say a location for it as well as give it an action. So notice here I have a grid that's 0, 2. And this is where I'm going to put the button. So I've extended my grid to be not just 0 and 1 and 0 and 1, but now 0, 1 and 2 and 0 and 1. So it's really a 3 by 2. And I have to define what happens when I hit the button. How I do that is with the action performed. So I have action event and event. So this is automatically called when an event occurs, such as a button is pushed. So this tells me to make the calculation at that point. Let's go ahead and compile this. And let's run it. So once again, I'm given a box to enter a value, but it doesn't calculate it when I hit enter. I have to actually push the calculate button. So the button tells it what to do. Once I hit the button, it makes the calculation appear in the correct inputs to calculate what the yearly salary should be. So now we want to talk about using formatted text fields. We can do that through using what's called a J-formatted text field, which is a Swing GUI component that extends the J text field in order to enable a programmer to specify the appropriate types and sequence of characters. So let's take a look at the example that shows the time to travel a distance based on a mode of transportation. Here we've got a very long program, probably longer than many that we've seen. And what happens is we input this value here, hit the calculate button, and it's going to calculate this information. Look at what we have to import to make this happen. So we have a number of AWT. We have a new one called Java Text Number Format, which is going to specify the format of the number we want to display. You can see we've got a number of variables, and we have to calculate both flight time and the driving time in hours based on a distance we're going to put in. So again, we do much like we have seen. We put our labels. We have a button that we create called calculate. And then we specify some of the labels and some of the values. And then we go ahead and put them on the grid bag constraints using the grid. In this case, it's a 2 by 2. So we're going to have 6 different components or elements that we're going to display. Once the buttons hit, we're going to do the action performed. So it's going to know to go ahead and make the calculation, and then we're going to make that calculation display in the right boxes. So if we put in a negative, we need to put in a positive distance value, and let's check that. So down in main, we create the frame, we set the default operation, what happens when we close it. We use pack because what pack does is it kind of compresses, as we know, and of course we need to set the visibility to true. So let's go ahead and compile this, close it, and let's run it. So again, believe it or not, this is a 3x3. So this is in position 0, 0. This is in position 0, 1. This is in position 0, 2. This label here is in position 1, 1. This is in position 2, 1. And this is in position, this is going to be 1, 2, and this is going to be 2, 2. So we specified the locations, and I'm going to put in a distance. First, I'm going to try a negative value. So I'm going to put -1 and calculate. And what happens is I get a message box that appears. And it tells me to enter a positive distance value. I'm going to hit OK, and it's going to take me back with my focus on this window. So I'm going to put in a decimal number, 29.04, and it's going to tell me in decimal format using a double what the time is for flying and what the time is for driving in terms of hours. Let's put another value. Let's put like a large value. And flying time, it's going to take 200 hours to fly 100,000 miles. And surprisingly, with driving, it's going to take approximately 8 times as long. What did we get from that example? Well, we know that we can format an object. So it specifies the formatting requirements for what we want. Numbers are one of the more tricky items because sometimes we want integers, sometimes we want to have them displayed with decimal points, but we don't want them to be as ugly as what we saw in that example. So number is general. We can have integers, we can have currencies, and we can have percentages. And another thing you might have noticed is we have a message dialog. And that creates a separate window to display a separate message. Notice we didn't have to specify a lot of information on that just because it's handled and all we have to do is provide a message value. Let's go back to that example. And here's how we specify that message value. We only have to tell it which dialog box that we're talking about, which is the current one. And then we also have to specify a message that we want to have displayed. We don't have to worry about all the formatting, the size of the box, because that's automatically handled for us using this method. Until now, we've looked at just basic text entry. What happens if we'd like to use some other types of user input to allow us to say, for example, select a box, we've got drop downs, we've got a set of values that we can do. We can even use sliders, which we'll look at in a couple of minutes. And what this does is this allows us to enter a valid age from a GUI that converts dog years into human years. Let's go to BlueJ and take a look at it there. So again, we've got these abstract window classes or libraries that we import. We've got a bunch of swing here. And notice that we've got one called JSpinner. So we also have spinner model, number model. So we've got a couple of things that are new to us for this example. So again, we extend and implement, but notice we're implementing a change listener, not an active listener. So it's a little different than what we just saw. So again, we have a dog years frame. We have initial values to put in. And again, we set those min, max years. And then if they go over the values, we want to display some messages. So dog's age in human years. So here we have a bunch of different values. So in the case, for example, of 9, we're going to put the value 57. So when we go over that, we put, that's a long life. That's what we're going to display, not when we get over 30, but when we get over 50. So again, we display the grid bag constraints, which allow us to put the layout in tabular format. We specify our buffer, and we also specify things like line end and horizontal. This tells us how the layout's going to look and how we're going to anchor it and how we're going to fill it. So again, these are our case statements. A lot of data that we need to load. So sometimes we can load it from files. We can read it in and preload it. Other times we have to use case statements like this. So we, of course, specify the new frame. We set the what action we're going to have when we close it. We're going to pack the values, and then we're going to set it to be visible. So let's go ahead and compile this and run it. So again, we're given a bunch of values, and you can see by changing them, it affects the case statement, so the human years. And then when we get up to above 14, we see it displays, instead of a number, it's going to display that's a long life. We can see that we can go all the way up to 30, right? So 30 was the limit, but anything over the value of 14, we don't have a specific case statement. So what we just do is we display that's a long life. So again, with the spinner, those are those arrow keys in the corner. We specify the types of values that we should be able to handle. In this case, it was 0 through 30, but we only had corresponding case values for 0 through 14. And then we had one general case for any value for a dog year that was greater than 14. So the listener object is used to handle the change events, meaning when we change the value in those dog years, you saw that it listened for that and it took some action based on that, essentially by updating through the case statement the value that appears in human. Sometimes we want to display multiple lines of text. And how we would do this is we use JTextArea to do this. So again, a lot of code here. And what we'd like to do is we'd like to show this in BlueJ. So again, you can see that we have quite a few different libraries to import. And the one that we're going to talk about now is we're going to use JTextArea. So that's this last one here. And then we also have JScroll pane. So again, we declare a bunch of variables. Now we have our calc frame. This is our constructor event, which is going to set all these to null. Now we create the labels and we specify the area, so the boundaries of the border. We specify a button and give it a label, which shows up. Next, we look at the currency format. So how we do that is we use this number format get currency instance, and then we use J formatted text field. So that's how we do it. We set it editable to true. Again, if we put false, it would be just for display purposes. And then we set the initial width to be 10 units. And here we set values, for example, for the rate field to be 0.0. And then we worry about the layout here. And notice we're seeing some boundaries. And then we have things like our anchor, which is line end or horizontal. And then we specify the actual location in that grid where we want each item to appear. So here's our action performed. So when we hit the button, this is what we want to happen. So we would do our calculation. And then this is where we do our main with the different components that we've already talked about. So let's go ahead and compile this and run it. So again, we have 4 editable fields, or 3 editable fields. But what we have to do is we have to be careful here, because if I just put 5 and I change this to 5 and I change this to 5, what happens is it just overwrites that as 0. So it's not very smart. So I have to make sure I put the $sign in. And when I do that, it actually calculates the values, not exactly in the prettiest format. You can see here in year 5, it goes way out past the 2 points after the decimal place, or hundredths, that I would expect with a dollar value. One nice thing is the JScroll pane, and that allows me to scroll through values. Let's take a look at that. So again, if I start with $10,000 and I put in a interest rate of 8%, and I'm looking at it for 20 years, it's going to put in this box a automatic JScroll bar. And you can see here that's automatically created because I went to 20, which is beyond what it can display. My initial display value is 10. And let's see, can I resize this? It doesn't redisplay the window, but the pack, what it does is it keeps them all together, and it doesn't do as much as I want, because I would hope that by dragging this box out, I could see all the values together, but unfortunately, the JScroll pane doesn't allow me to do this in this context. Now, there are times when I want to use tables in GUIs. So this allows me to display things in tabular format for the user. And again, you can see there's a lot of code. So let's take a look at some of these in BlueJ. So again, we have JTable that we're adding here. So JTable is what's going to allow us to display a table. I'm going to skip over a lot of these, but what it's going to allow me to do is type in a bunch of values, and it's going to find the maximum. So one thing that we notice here right away is that we have an action performed, and that's going to be tied to, take a look here, by compiling and closing and running. So here I've got a number of elements, and I'm just going to replace those with numbers, and I'm just putting the values in here, and we'll see which one is, by calculating which one of these values is the highest. Okay. And it came up by saying 103, so that means there's a... So what happened is I had 104 here, and I hit find max, but because I didn't move out of it, it didn't actually do anything with the number. But when I move out, it recognizes that. So there are some limitations to what we can do, but by changing some of these values and moving out so it loses the focus, I'm actually able to use that, and by hitting the button, it recognizes the replacement number. So this allows me to use it in tabular format, and by hitting the button, it takes the action of finding the maximum value. One of the last components is called JSlider. So what JSlider does is it gives you a slide bar, and you can actually change the value in the slider. So you have a minimum and maximum. By sliding the value back and forth linearly, you can actually change the value of the input. So let's take a look at some of the code that's involved with that in BlueJ, and hopefully we'll get something that looks like this. So in this one, we're adding JSlider. So JSlider is going to be the actual object that we're going to use to change the values as inputs. And you can see here we have our final values. So these are going to be static. cm per inch per feet. These don't change through the life of a program. So we not only declare them as capital letters as the variable name, but we put final and static in there. So here is where we specify the frame for the minimum and maximum values. And again, we put our labels. We set tick spacing, so we have a lot more control using these sliders than we do with other types of inputs. We can add a listener, so the height convert, we can change the state, and that will actually change the values. And we can do the other things with the inches as well. We specify where we want them to appear, and here's where we do the calculation once we take action. And again, here's our change event. So we have two sliders. So we have two different events we have to handle. So two different source events. One is if we change the height to feet slider. The other one is we do the height inch slider. So let's go ahead and compile and close this. So when we run it, of course, it takes a little bit of time to load because Java is very slow. But here you can see 5 foot 8 inches by converting is 172 centimeters. So if I convert this to 6/8, I get a different value. This is our sliders. And notice that I have two different listener items. So what happens is if I change one or the other, it's going to actually change the value that's used for input. So one of the things we need to realize is labeling every foot and inch value, we just put tick marks here in this example. But if we wanted to label the different values, we would have to do different things that require a lot more input and a lot more code. However, if you create it in one place and then you extend the object for example, for new windows, it makes it a lot easier because that's already been done. And that's one of the benefits of having object-oriented design. So I hope this has given you some insight into what you can use GUIs for. Now, there's a whole lot more that we aren't going to cover in this course, but I encourage you to explore it a little bit further on your own. The examples that we have inside Zybooks are going to be useful to you, and I encourage you to look through it and explore.